Hi viewers, welcome to all. Here we are discussing about a project design of scalable low power 1-bit hybrid full adder for fast computation. This paper introduced a novel hybrid full adder architectures based on past transistors, transmissions gate and conventional complementary metal oxide semiconductor logic. For the comparative study, the efficiency of the parameters have been compared with 20 number of existing hybrid full adder design and finally get the proposed modified full adder using transmission gate and past transistor method. It will reduce the huge logic sizes and power consumption. Similarly, this fast computation hybrid full adder design will applied into the 8-bit truncated multiplier and proved the performance of the multiplier efficiency with a number of MOSFET reductions and power reductions. Similarly, in order to verify its scalability, the proposed full adder has also been expanded up to a word length of 64 data bits. This proposed method of hybrid full adder architectures will more suitable for reasons high-speed central processing unit. This work was designed in Tana EDA tool at 22 nanometer and 16 nanometer CMOS technology. This design outperforms in terms of power consumption and latency in very low level. Okay, now we can verify the base paper. This is a base paper title and base paper abstract. Now we can verify the simulation architectures. Okay, in the figure 1 architectures will show the hybrid architecture of this full adders. Okay, here it will be have the model 1, model 2, model 3, model 4. This 3 and 4 model will contain as a different architectures. Okay, example, the model 1 will have a AND OR architectures and model 2 will have a TG transmission gate architectures and model 3 will have a XOR gate architecture and model 4 also XOR gate architectures. So once you are given as an input A and B, the model 1 will split the input AND gate output and OR gate output. It will be given to the model 2. The model 2 will provide as a carry output and model 3 will get the input of A and B and it will be XOR. Again it will be XOR into the model 4 will be get a sum output. Okay, so this is the architecture of the proposed full adder design. This proposed full adder design, the same architectures we are developed into the Tana EDA. Okay, this is a test bench of the Tana EDA. Here we are given 0.5 volt and it will be simulated in CMOS 16 nanometer MD5. Okay, so now we will run this architectures. This is a simulation architectures. Okay, so once you are run, you will get the waveform WEdit. Okay, so here you can verify the input and output. Okay, here A is input, B is input and sum and carry. Okay, so here you can check 0 0 means sum will be 0 and 0 1 means sum will be 1 and 1 0 means sum will be 1 and 1 1 means carry will be 1 and sum will be 0. Okay, so this same architecture of this full adders will be integrated into the multiplier concept. Okay, we are used the proposed multiplier is 8x8 truncated multiplier. This 8x8 truncated multiplier will reduce the number of logic sizes in the multiplication concept. Example, you are using a normal 8x8 multiplications, it will be get a 16-bit output. Okay, but in the truncation multiplier case will be get a 8-bit only. Okay, in a normal multipliers it will be have the 3 different type of reductions we are processed in the truncated multiplier. Okay, so here this is the architecture of the normal standard multiplier concept. Here if you are multiplied the 8x8 bit means we will get a 64 partial product. For the 64 partial products we are used to reduce the number of half adders and full adders. So in this case we are removed this conventional full adders and we are placed the proposed full adder in this area. Okay, so here this partial product reductions we are used the 3 method. Okay, so one is a deleted method and deductions method and truncated method. Okay, this is the truncated multiplier architecture. The figure 5 will show it. Okay, so based upon this architectures we are developed the truncated multiplier on here. Okay, so this is a truncated multiplier. Okay, this is a 8x8 truncated multiplier. As per the input low and high, okay, we are given the data. Okay, so if you want to change this input you can change it and you can check the output. Okay, so this is a truncated multiplier architectures. So initially we will be get a input and B input. For that A input B input the sign bit logic we don't know, that's why we are given as a 2's complement concept on here. Okay, so first of all we will be invert the input and additional inverter plus 1 logic, that is a 2's complement logic. First we will be get a 2's complement and B 2's complement and will be put on multiplexer. Okay, it will be switch if the A is a high, the sign bit is a high or sign bit is a low. Okay, based upon that it will be switch the data, it's an inverted bit or normal bit. Okay, so finally we are taken the data and it will be given into the number of partial product. Okay, so here this is a partial product generation. Okay, So here it will be given the A0, B0, A0, B1, A0, B2, A0, B3. So totally 64 partial product will be get the output. Okay, so we are taken only the used partial product on here, and it will be given into the truncated addition. This is a truncated addition. Here we are used as a same the proposed full adder method. Okay, so this output will be get on here. Okay, so P0 to P8 to P15. Okay, only MSB part only will be get the output. Again, based upon the input, we will just complement the data again, and we will be get the output on here, out 0 to out 7. Okay, so once you are simulated this, you will get the output on waveform. Okay, so this is the output waveform. Okay, so here you can check the data. Out 1 is equal to 0, and out 2 equal to 1, out 3 equal to 1, out 4 equal to 1, and out 6 means it's a 0, and out 7 means it's a 0. Okay, so based upon the voltage level, we can calculate it's a 0 or 1. Okay, and you can verify the power and area reports on here. Okay, so this is a power report, and number of MOSFET logic will be given on here. Okay, so this is a netlist for your truncated multiplier. Okay, and finally we have taken all the comparisons on here. Okay, this is a comparison for 16 nanometer and 22 nanometer for single bit and 64 bit. Okay, and this is a truncated multiplier with using 1 bit hybrid full adder logic for 16 nanometer CMOS technology and 22 nanometer CMOS technology, and data width is 8 bit, and the MOSFET is 1537, and input voltage is 3 and 3.5. area we are calculated number of MOSFET into nanometer. Okay, so here 1537 into 16 nanometer means we will get this value. Okay, and power we are calculated from the comparisons. Okay, and this is a comparison analysis chart. Okay, and we have written abstract document for this project. This is the title and objective of this project, proposed title and proposed abstract, disadvantages, advantages, applications, introductions and disadvantages, proposed systems, and related notes for this project. Literature survey, finally references. Thank you.
If you need more video related to VLSI project, please like and subscribe this channel.